Alright, this next unit is Unit 7. We're looking at genetic technology. There are just a few things that I want to go over genetic technology. The first and most important thing that I hope you see on the EOC is gel electrophoresis. Can you spell that yet? Just kidding. So gel electrophoresis, we are using that to identify crime suspects, and we're also using it to identify parents of a child. So the two different types are very different, but very similar at the same time. Number 87 on your review guide. That's what I'm looking at right now under Unit 7. So it says identify the DNA sample that matches the unknown sample. Whodunit. So you look at the unknown sample on the left-hand side. As you look at it, you're going through and comparing each band of the unknown to all the other samples. You should be able to find an exact match. So if we go through the first line, you see that band number 1 matches B, C, D, E, and F. We can't cross out any sort of suspects at that point. The second band only comes across D and F. Since B, C, and E do not have it, I'm marking B, C, and E out. I go down and unknown has band number 4. They all have it, but I've already marked some of them out. 5, it looks like D has it and E has it, but now I see that D, as I keep going through, D is the exact match. Ignore band 10, I don't know what happened there. Now if I'm doing this for a parent, or for parents and a child, please keep in mind, a child's DNA is part of their mom's and part of their dad's. It's not going to exactly match mom or dad. It's going to be part of mom and part of dad. Usually they'll give you the mother, because obviously the baby came out of the mother, so we know it's mom's. And then for dad, you got to figure out which one matches the other half of the DNA. That's the biggest difference in gel electrophoresis between parents and suspects. Second thing, clones. They're all over the news lately, but clones is making an exact copy of an organism. We do this by taking out an egg cell, taking the DNA out of an egg cell, putting the clone's DNA into the egg cell, reinserting that, and then it's going to be born. So, if we made a clone of you right now, you'd be a baby in 9 months. Does that make sense? You're not going to be an exact copy and just, here's somebody else. Not happening here. Next thing's a transgenic organism. Kind of the same idea. We see a gene we like. For example, let's use the dog and lion. The dog with the lion's mane. It's not real. I was just playing with you guys. But, as an example, we take the mane, that gene of a mane of a lion, out of the lion and insert it into the dog's DNA and replicate, and then we're going to let that be born, and now we have a dog with the lion's mane. Silly example, but one that will stick with you, I'm sure. Stem cells. Stem cells allow us to create all sorts of different cells. There are 2 types. There's adult stem cells, embryonic stem cells that we have to get from fetuses. That's why people don't like them. But if they're fetal stem cells, they can be any sort of tissue or any sort of thing we want them to become. If they are adult, they're very limited as to what they can become. Just keep that in mind. And last thing I wanted to go over was gene therapy. We are using different genes from different people for therapy for such things like cystic fibrosis. Other than that, that's pretty much it for genetic technology or biotechnology, whatever this unit is, and have a great day.